cube root of 2x minus 4 minus 2 equals 0, before you start trying to undo that cube root, you want to get this by itself. So I'm just going to add 2 over. So I would get the cube root of 2x minus 4 equals 2. And then again, you're solving an equation, so you're just undoing things. How would you undo a cube root? You would cube it. If you're going to do a square root, you would square it. So if I cube this side, you just have to remember to cube the other side. Because a cube and a cube root cancel each other out. I'm going to come up here. And I would just be left with 2x minus 4 equals 2 to the third power is not 6. It's 2 times 2 times 2 is 8. And then once you do that, you're just solving that, right? So I'm just going to add 4. And I'm going to get 2x equals 12 and divide by 2. And I get that x equals 6. You do want to make sure you check your answers. Cube root's not such a big deal because you can have a negative under an odd root, right? Like you can take the cube root of negative 8. You can take the cube root of negative numbers. But if you have an even root, sometimes you get those extraneous solutions. So you don't have to show me that you're checking it, but it's not a bad idea to just mentally say if I plug 6 in there, 12 minus 4 is 8. The cube root of 8 is 2. 2 minus 2 is 0. Okay, that works. Right? So it's not such a bad idea because sometimes we get answers that don't actually work, and then you get the wrong answer. So check your answers. I'm going to write that. Check your answers.
Check your 8.
What about if I gave you something like this? Right, we can't be that simple on all of our homework. That wouldn't be college algebra. That would just be algebra. Step 1 is get the radical by itself. Is the radical by itself? Yeah. Step 2 is how do I get rid of the radical in this one? And that's a square root. So I'm going to square both sides. We can see how there's a little more work to do in this one. Oh, foil. Right? So on this side it's easy because the square root of something squared is just x minus 1. But on this side, x minus 7 squared, that is not just x squared plus 49, right? That's x minus 7 times x minus 7, so you need to actually FOIL that out. And we get x squared minus 7x minus 7x is minus 14x in the middle, and plus 49. Number 1, we only had x to the first power, so we just got x by itself. If you have an x squared and an x, that's a quadratic. You're going to have to either complete the square, factor, or do the quadratic formula. I don't care which one you do as long as you get the right answer. So I'm going to move everything over and see if I can factor it because I love to factor. But if you hate to factor, quadratic formula works, completing the square works. I think I'm going to get x squared minus 15x plus 50. Oh, I really love to factor when there's just an x squared in front. So I'm going to ask myself, can I think of two numbers that multiply to give me 50, that add to give me 15? 10 and 5? See how factoring just never goes away from us? So I would love it so much. Factoring is in my top 5 favorite math things to do. Factoring. Quadratic's not my top 5. You know what my number 1 thing is? Those rational things where you like factor everything and then you cross things out and oh, it's my favorite.
You're getting really excited.
That's how I said my Saturday nights. It's subtraction. So minus 5 minus 10. We're solving this, right? You did something like this on your quiz yesterday. Solve by factoring. So now you set each one equal to 0, and we can say x equals 5 or x equals 10. Yes? You are a weird guy. Proofs are kind of cool, but most people hate them. I didn't like them until I was a teacher. Again, we want to check this and make sure that it works up here. So I'm just going to kind of erase this and make sure that you get a true statement up here. If I plug 5 in here, 5 minus 1 is 4, and the square root of 4 is 2. Agree with that? And if I plug 5 over here, 5 minus 7 is 2. So that's good to go? Wait,
Why would that be negative?
oh my gosh! You're right. minus 7 is not 2, it's negative 2. I just missed that problem because I got in a hurry. 5 does not work. Does 10 work? 10 minus 1 is 9, the square root of 9 is 3, and 10 minus 7 is 3. So that's why you have to check your answers, because sometimes they're called extraneous solutions. It works algebraically, but it doesn't work when you plug it back in the square root. So check your answers is the message of the day. What else can we do? Oh, how about a fourth root? And a square root over there. Oh my gosh. It's a fourth root and a square root. This is exciting now. You didn't do this in algebra 2. So if you see two roots in the same problem, my advice to you is get rid of the bigger root first. Like you have a fourth root and a square root. Let's get rid of the fourth root, and then hopefully magic will occur, or math, and the square root will disappear too. So how am I going to get rid of a fourth root? Fourth power. But if I fourth power that side, I got to fourth power that side. He's so excited. Vaughn's such a nerd. I love it. I wish all students were like Vaughn in terms of being excited about math. No one ever gets excited about math anymore. Fourth root of fourth power cancels out, and you're left with x squared plus 16. See, Vaughn, I think this is a good message of why you should be a teacher, because you're excited about it. Everyone else is just like, oh my gosh, this is not fun.
I don't know if every kid does that.
The square root of 5 to the fourth power. You could just do that on your calculator, but you don't need a calculator, because if you had the square root of 5 squared, do you agree that that cancels out the square root? So how many square root of 5 squared do I have if I have the square root of 5 to the fourth? Could I write it like this? And again, your calculator, you can just type this in your calculator. The square root of 5, close the parenthesis to the fourth power, and it's going to tell you the answer is 25. And that's because the square root of 5 squared is 5, and the square root of 5 squared is 5. So you just get x squared plus 16 equals 25. How do we solve a problem like this that just has an x squared in it? Do I need to do the quadratic formula? You could do the quadratic formula. B is 0. And you could move the 25 over, and it would work. But it's really like way more work, because you could just do the square root formula. Could we just get x squared by itself and then take the square root of both sides? So the square root property is a nice one to do. So if I was doing this, I'm going to subtract 16 over. And we get x squared equals 9. Or I guess I could subtract 9 and factor. That would work too. But I like this square root, square root. X equals plus or minus 3, right? I think both of these are going to work, as long as one of them works, because when I plug this back in, I'm going to square it, right? So I'm going to get 9 plus 16, which is 25, and the fourth root of 25 is actually the square root of 5. How about that? Whoa. See, this is some good, fun Friday math here today. What else can we do? Oh my goodness, here's where the real excitement happens. See how the first example was just like, oh, this is going to be so easy, and then like each one it just gets worse. The good news is I tried to pick all different kinds of problems that are on your homework today, so that all the problems today you'll have an example to look back at, is what I'm hoping to see. Remember my rule at the beginning was get a square root by itself. We have 2 square roots here, but you still want to get one of them by itself before you start squaring both sides. I guess it really doesn't matter which one you get by itself, but to me it makes sense since this one is a minus. Can I add this square root to the other side? Not really going to accomplish a whole lot, but it is going to get this square root by itself. So I can add the square root of x plus 2. So I get the square root of 2x plus 3. You can't add something with a square root to something without a square root, so I'm just going to write that as 2 plus the square root of x plus 2. And the only way to get rid of a square root in a problem is to square both sides. So get one square root by itself, and then we have to square both sides. This side's easy. This side not so easy. Right, you can't just square this and square this. You got to square the whole quantity, which means we get to FOIL with a square root in it. Hope you left some room on your paper for this one. Okay, ready? This side I just get 2x plus 3. Now this side there's 2 of these, so I'm going to write the other one out here. Instead of writing the squared there, I'm going to write 2 plus the square root of x plus 2. I'm just going to FOIL. 2 times 2 is 4. 2 times the square root of x plus 2 is just 2 square root of x plus 2. That's my first, my outside. So now my inside. Man, Vaughn, how does your crazy factor FOILing way work with this? Does it still work?
Yeah.
2 times the square root of x plus 2. He does like this crisscross method, and I don't even know. It's like he's... And then what am I going to get when I take the square root of x plus 2 times the square root of x plus 2? Just x plus 2. So all of that is what you get when you FOIL that out. Which means by doing this, do you agree we got rid of one of those square roots that was in there to begin with? So we're still a long way away from the answer to this problem because we still got a square root to deal with. So let's clean this up a little bit before we go on. So 4 plus 2 is 6 plus x. And then I can add these together because they both have the same square root. So 2 square root of x plus 2 plus 2 square root of x plus 2 is 4 square root of x plus 2. And we're kind of back to this could have been the original problem. We have a square root in here. So now I need to get this square root by itself and square both sides. So now I need to move this stuff over. And go again. It's like two problems in one. Oh yeah, let's look at this. It does kind of get a little messy here. So I'm going to subtract x. And I'm going to subtract 6. We're not subtracting 4 here. 4 is multiplied by that, so hold on to that 4 for a second. And we would get x minus 3 equals 4 times the square root of x plus 2. We have a choice. Hold on, we'll figure it out if we want to divide. You don't have to. I've always said, especially in algebra 2, you need to get the square root completely by itself, which means we'd have to divide by 4 here and we'd have a 4 in the bottom. But you don't really have to, because the reason that we get the square root by itself is so when you square both sides, you don't have to FOIL. If you square stuff that's multiplied together, are you allowed to just square this and then square this separately? Does that make sense? And so, if you had, if this was just 4x, and you were trying to square it, you're allowed to just square the 4 and square the x. And so you don't have to divide by the 4, because then you have a fraction over there, and you probably don't want that anyway. You could, you're going to get the same answer. But I think it's probably better not to divide. I think it looks better, saves you a step. But the only reason we're allowed to do that is because that's multiplication. You do need to move the addition and subtraction, otherwise you just get a big giant mess in this problem. You're okay with me on that if I don't move it? So now I'm going to square both sides. Otherwise we have to square a fraction, and that's not fun. Oh man, we get to FOIL again. This is like the best problem ever. So I get x squared minus 6x plus 9 on that side. What do I get over here? 4 squared is 16, and then just times x plus 2. Oh my gosh. We finally got to the point that we got rid of those square roots, right? Now we just got to distribute that 16 and solve for it. We're in the home stretch now. How much paper have you used so far on this problem?
No.
Some of you write really small, and some of you write really big.
And I don't show a homework.
So that would be 16x plus 32. Again, that's a quadratic. There's an x squared and an x. So I'm going to move everything over to one side. Look at all this math was just used in one problem. This could be like your test, one problem.
So,
We should just start with a really hard problem one time and then come back home and just read easy ones.
I would cry in the beginning.
Then everybody would think that the rest of them would be.
21, is that right? 9 minus 32.
23.
yeah.
Or you could factor. Most of these today are factorable because, you know, if they're going to make you do all this other work, they could at least give you something at the end that's factorable. That's them being nice. Completely square would not be a bad choice on this one, but I think because we're subtracting to get 23, 23 is a prime number, it's got to be 23 and 1. And you just got to make sure you get your signs right. Minus 23 plus 1. You know what would really stink on this? If we get these answers and neither one of them work. Wouldn't that be awful? You're not going to check your answer after all that?
I think she put in the game.
No, I don't know. I haven't done it yet. I'm kind of a slacker in this class, and I don't really work out the notes ahead of time. I just wing it because I like doing it so much. No, I just trust that I'm good at algebra, so I don't work them out ahead of time. So, 23 and negative 1. Let's see how far I have to go to this.
I would be extremely mad if you
Let's do negative 1 first, because I can do that one in my head easier. That would be negative 2 plus 3, which would just be 1, right? The square root of 1. And this would be negative 1 plus 2 is 1. Oh. We get 1 minus 1 equals 2. That's not true. So negative 1 is out.
You better give us problems on this quiz or whatever, if that actually works.
I bet 23 works. 23 times 2 is 46. 46 plus 3 is 49. So the square root of 49 is 7. 23 plus 2 is 25, and the square root of 25 is 5. 7 minus 5 equals. Check your answers, kids. Can't get any worse than that, right?
should go to the next grade.
No, I don't think it does. I think there's just something that's not so bad, but I just want to show it to you. But I could be lying. I don't remember. Oh, I don't think we should do another one of those. Do you agree with that?
I agree.
All right, let's change this to number 5. What was I thinking? Putting 2 of those on there. I think I forgot how much work those were. I just want to show this because at the end of your homework they write it like this, and we talked about fractional exponents already, but I just want to make sure you would know how to do these problems. Remember that a fractional exponent is the same as a root, right?
Yeah.
So if you wanted to, you could just change that to the cube root of 5x minus 2. It's the same thing. But even if you don't change it to the cube root, you still solve it the same way. How do we get rid of the cube root? We take it to the 3rd power, right? So I just want to show you on this. If you left this as the 1/3 power, look what happens if I cube that. I just want to show you why it works. We change it to cube root, I promise. But what do you do with exponents when you have 1/3 to the 3rd? What does that equal? It just equals 1, right? So you see how the reason that we undo a cube root by cubing it is if you write it with the exponents, they still cancel each other out. By no means do you have to do it like this. You could write it like this, the cube root of 5x minus 2, just like we did before. But there's like 2 problems on your homework, and they're at the end, so you'll do those really hard ones, and then you'll get to these, and it'll be a nice breath of fresh air after the one we just did. And then we just get 5x minus 2 equals 8. Look, we end like the same way we started with such a nice problem. don't know if I have another one or not. Let's see.
Yeah, just do it.
I did already in my head. You get 8 to the 1/3, which is 2. Oh, look. Here we go. Check your answers. You're doing 3 through 36 multiples of 3. Let's see how many are the terrible ones. I don't think it's that bad. It's 12 problems, kids. That's not a lot of problems.
For a week.
And 8 of those
It's 12 problems, and you have 22 minutes to start those 12 problems. So I don't want to hear it.
8 of those 12 problems are the hard ones.
No. Okay, just kidding. You can't start at 3 because there's not even a 3.
So we start at, say,
9. You start at 9.
hey, so we don't even have 12 problems.
Well, I mean, it's like way at the top. Like, are you prepared? Not like the actual problem. Like, it's like review, and then there's vocabulary, and I don't care about those. Who needs vocabulary? You can do it. I don't want to do it. There are 2 bad ones. 2. And I will tell you, I will not be doing both of those on the board on Monday. I might be convinced to do one, but I'm not doing both. 27 and 30 are the 2 bad ones. 24 sounds bad. The first 5 are not bad, and then the last couple are bad.